Hello, fellow programmers. Welcome back to this C++ video. We are going to go over algorithms today. Before I get into the video, I just wanted to let you guys know that we are not actually going to get into much C++ programming for the next couple of videos. We're going to go more over the basics of C++. Um, After that, we're going to get more and more involved into programming with C++, and we're going to do lots and lots and lots of examples. And by the end of the semester, I hope to do 2 or 3 projects with you guys so that it helps you understand all the concepts better and how to manipulate each of the concepts better, all of the features better, and to help you become better programmers in C++. Well, without further ado, let's get into this video. So what are algorithms? Algorithms are a finite set of well-defined instructions that can be executed by the computer. A computer doesn't know how to read human language or how to execute different tasks without it being told exactly what to do. So we need to give the computer specific instructions to run and execute in order to complete a task. So these sets of instructions, which are step by step given to a computer, uh, are called algorithms. So these algorithms can be used for solving problems. They're also very good tools for solving well-specified computational problems. Let's look at some specific examples. For this example, we're going to write an algorithm to go from our house to our school. For that, at first we need to put on good clothes. And then we need to get car keys, our wallet, and our ID card. And then we need to lock our house door. And then we need to get into our car. And then we need to start the car engine. And then we need to set the GPS to the school. And then we drive to school. As we can see, we need to put a specific set of directives. These are very specific set of instructions to follow to go from our house to our school. Similarly, we need to give the computer very specific instructions like these to execute programs. And these are what we call algorithms. Let's look at another example. In this example, we're going to write an algorithm to run a program that calculates the sum of 2 numbers, which are input by the user, and then it outputs the result back to the screen. For this, at first, we tell the computer to make 2 input variables called num1 and num2, and then take input from the user. After that, we add the 2 numbers and store the sum in a variable that we call result. We can call it anything else, but for convenience, I'm going to call it result in this video. After that, we print the result back to the screen. And in this way, we can add 2 numbers, which are input by the user and outputted back to the screen. For this next example, we're going to take a look at the set of steps. Are these set of steps an algorithm? Why or why not? Let's take a look at it. At first, in these steps, we set a variable called I equals 0. And then we check if I is smaller than equal 1. And we know that 0 is smaller than equal 1. And we see that the condition for this checking is that if the statement is true, if I smaller than 1 is true, then we need to go to step 3. Else, we need to go to step 5 to terminate the program. In this case, we see that 0 is smaller than 1. So the statement is true. So we go to step 3, which tells us to print hello there. And then it tells us to go to step 4, which tells us to go back to step 2, which checks again if I is smaller than equal 1. So I was never updated, so I is still 0. Because I is still 0, 0 is still smaller than 1. So we go back to step 3 again, and we print hello there, and go back to step 4, and then go back to step 2. So this is what we call an infinite loop. This will keep printing hello there over and over again infinitely until there is a stack overflow. And it'll never terminate the program. So this set of steps are actually not an algorithm because they never terminate the program. For a set of steps to be an algorithm, the steps need to be finite and they need to terminate the program. So let's take a look at this last example and we're going to wrap up the video for today. For this example, we're going to write an algorithm to sort a set of numbers in ascending order. For that, we tell the computer to store all the numbers in an array. So what is an array? An array is a set of contiguous memory locations that store a certain type of data. They can be similar data or different types of data. As you can see, these boxes on the right represent an array, and each box represents each memory location for a data type. And in this case, each box represents an integer data type, and they store integers. And as you can see, the numbers below the array represent the position of the array. And the position of arrays start from 0. That means the first element of the array is stored in position 0 of the array. We're going to discuss more about this in later videos, but for now, let's get back into the example. After that, we set a counter variable called I equals 0. That means I is pointing to referring to the first element of the array. And we set j equals I plus 1. So for now, j is pointing to the first index. That means the second element of the array. After that, we set the element in position I in the array to lowest. That means the element in the first position now is the lowest element. So after that, we check if the element in position I is greater than the element in position j of the array. That means we check if 3 is greater than 5. But 3 is not greater than 5, so the statement is false, so we go to step 7. And step 7 tells us to increase j by 1. And after that, we check if j is smaller than size of the array. In this case, for our example, the array holds 5 elements, so the size of the array is 5. So because that's true, because j equals 2 is smaller than 5, we go back to step 5 and we check if 3 is greater than 1. And 3 is in fact greater than 1, so because that statement in step 5 is true, we go to step 6, which tells us to swap the elements in position I and position j. So we swap them. Now, the element in position I is 1, and the element in position j is 3. After that, we go back to step 7 and we increase j by 1. And we go back to step 5 because j is smaller than the size of the array, and we check if 1 is greater than 2. Because it's not, we increase j, and we check if j is smaller than the array, and 4 is smaller than 5. So we check, we actually go back and we check if 1 is greater than 4. Because it's not greater than 4, we increase j, so now j will be 5, and 5 will be equals 5 after we increase j in step 7. So because 5 is not smaller than 5, we are going to go to step 9, which tells us to increase I. And we check if I is smaller than the size of the array. So we increased I, and we check that I is smaller than the size of the array because 1 is smaller than 5. So because that's true, in step 10, we go back to step 3, which tells us to set j equals I plus 1. So j now points to the third element of the array, and I points to the second element of the array. And after that, we set the element in position I in the array to lowest. Now, since our first element, we checked it with everything, and we swapped if it was greater than anything else, so now the first element has to be the lowest number in the array. So we sorted one of the numbers. Now we're going to do that for this second element. So we set the second element to the lowest, and then we're going to go through the array like we did for the first element. So we check if 5 is greater than 3. Because it is, we increase, we actually swap first, and then we increase j by 1, and then we check if j is smaller than the size of the array, which it is. So we go back and check if 3 is greater than 2. Because 3 is greater than 2, we swap them, and then we increase j, and we check if 4 is smaller than 5. So 4 is smaller than 5. So we go back and check if 2 is greater than 4, but it's not greater than 4. So we just increase j again, and since j will be 5 after that, it's going to go outside the array. So we're going to increase I and set j equals I plus 1. And now our third element is the lowest element. So after that, we check if 5 is greater than 3, which it is. So we swap them again. And after that, we increase j. And since j is still smaller than size of array, we check if 3 is greater than 4. But 3 is not greater than 4. So we increase j, but j will be 5 after that. So we increase I. And then we set j equals I plus 1. So after that, we check if 5 is greater than 4. Because 5 is in fact greater than 4, we swap 5 and 4. And then we check, we increase j actually. And after this, j is going to be outside the array because j is not smaller than size of array after we increase j. So we're going to increase I and set j equals I plus 1. And since j is I plus 1, j is going to be 5, and j is not smaller than size of array. So we're going to increase I after that again, and I is going to point to 5, and I is not going to be smaller than size of array. So because that's true, because I is not smaller than size of array, we go to step 11 that tells us to print the array. So what we're just going to do after this is we're just going to print 1, 2, 3, 4, 5. And we have a sorted array. So if you need extra practice, you can go over this practice problem to write an algorithm to sort a deck of cards in ascending order. Um, so for this, we're going to assume that spades is greater than clubs, which is greater than diamonds, which is greater than hearts. So we're going to place spades on the bottom. All of the spades cards are going to be on the bottom, and then the clubs are going to be on top of spades, and then diamonds, and then hearts is going to be on top. So, and then we start from 0 for each set of card, and we're going to go all the way down to 9, and then jack, queen, king, and then ace. So that's it for today's video. Thanks for watching, and don't forget to like, share, and subscribe. Have a good one.